Hello again. So here are some of the SIG compiler goals. So we try to shape the Onyx specification to make it implementation friendly, and I think I mean much progress has been done, but it's still sometimes challenging to implement to have an unambiguous, lean, and well-documented specification. We build shared Onyx compiler infrastructure, and at this time it's mainly focusing on Onyx MLIR, and we also try to keep abreast of other Onyx compiler efforts and to strengthen the overall Onyx usability in this space. So we are a fairly active community. So several companies are contributing directly. We have switched to a monthly SIG meeting, which is at 8 to 9 p.m. on the first Tuesday of the month. And we have about, last year we had about 300 PRs by more than 30 developers and quite a bit of forks. So I think it's fairly active. So I presented these slides before, but let's just reiterate a little bit. So basically, the infrastructure is mainly with the Onyx MLIR for the compiler side. Again, we take Onyx models, and then we generate various different levels of Onyx dialects. Including an Onyx dialects. We also do transformation directly. It's not a one-to-one mapping. So some of the things like the pattern substitutions and handling of different versioning of the specs is done there. So it's not a direct translation. And obviously then there's a TOSA, stable HLO, and LVM are being done there. So some of the recent developments on the infrastructure for us. So obviously we continue updating to the latest upsets. We have migrated the HLO to stable HLO, which is like the new, basically stable versions, which is used in other projects. We include support for more quantized operations, so it's still a bit of a weakness there, but we're making progress here. And then, as I presented before, there's exploitation of data in functional parallelism, transformation to enhance the parallelism in the graphs, and using OpenMP dialects to do basically parallelization. And that's when you go directly to binary, obviously. So recently we were made aware of some other efforts, and so this ARI has now an Onyx importer, so it's being actively developed and actively modified, so they don't consider it quite stable there, but I thought it was interesting, and we're going to have an ongoing discussion with this team as well. So they take an Onyx protobuf and they have an importer that goes to a Torch MLIR, and then that can be fed to the ARI compiler, and you know, various different companies use the ARI compiler for it can also be used for their own pipeline, other pipelines. So as long as it's compatible with the Torch MLIR. And ARI is in the process of being an LFAI project, so it's also very well integrated with the Onyx community. And some of our aspirations is to continue try to being more proactive for role for operations, making sure the operators are consistently and unambiguous, making current Onyx compiler infrastructure more attractive, and also reaching out to other deep learning compiler platforms. Any questions? Thank you.